Okay, this is a basic partial fractions type of integral. I have an integrand with a rational function in it, and in this case I've got two linear factors in that rational function. And the basic idea of partial fractions is, well, if I see a rational function with an x minus 3 and an x minus 2 in the denominator, maybe that came from adding up two simpler rational functions and finding their common denominator in order to add them. And so I make a proposal like this, and then I do the algebra to figure out what the a and b are. And my usual method here is to multiply both sides by the least common denominator. And when I distribute that x minus 3 to x minus 2 to the term on the left, I'm going to get a 1. When I distribute it to the a containing term, the x minus 3 is going to cancel, and I'm left with a times the quantity x minus 2. When I distribute it to the b containing term, the x minus 2 cancels, and I'm left with an x minus 3. And the approach I'm going to take on this one for finding a and b is to use substitutions. So this equation needs to be true for all x. So it's true for any x you want to choose. So I'm going to do a substitution and say let x equal 2. Well, that would kill the a containing term. I would have a times 0. And then in the b containing term, I would have a 2 minus 3 or a negative 1. So I get negative b. So my left-hand side was 1. My right-hand side is negative b. And I find out that b is negative 1. Then I do another substitution. Let x equal 3. Then the b containing term is going to vanish, and the a containing term is going to have a 3 minus 2 on it, in other words, a 1. And I end up with a equals 1. So I've just re-expressed this integrand as a sum of two simpler fractions. A is 1, so look at our original proposal. Replace a with 1, and I get 1 over x minus 3. B is negative 1, so I get minus 1 over x minus 2. And each of these pieces is quickly guessed. These are both natural logs, so this is natural log absolute value x minus 3 minus natural log absolute value x minus 2 plus c.